Have you ever looked up at the night sky and wondered about the scars scattered across our moon? That classic bowl-shaped depression you see right there is the cosmic aftermath of an ancient space rock violently smashing into the lunar crust. Generally speaking, these massive dents are born the moment a wandering comet or stray meteor violently collides with the barren landscape. The moon is absolutely covered in them, but there is one specific giant basin with a completely unique origin story. So what exactly carved it out? To understand that, we need to dial the clock way back. The leading scientific theory actually suggests that our glorious, glowing neighbor was born from a catastrophic impact, much like the very craters dotting its face. Except this primeval smash-up was on an entirely different scale. Picture this. Over 4.5 billion years in the past, a rogue planet roughly the size of Mars, known as Theia, slammed head-on into a young Earth. The sheer force of that collision launched a colossal cloud of planetary rubble out into space. Over countless millennia, gravity stitched that wreckage together into the satellite we know today, though initially, it was nothing more than a boiling, spherical ocean of molten rock. In those early days, this fiery sphere orbited incredibly close to us. The relentless gravitational pull from our world basically kneaded the young moon like dough, generating immense internal friction that cranked its temperature even higher. Eventually, it retreated deeper into the void, shedding its heat until a solid, rocky shell hardened over the exterior. Fast forward to about 4.3 billion years ago. Imagine an asteroid as massive as the entire nation of Nepal, dwarfing the infamous rock that ended the dinosaur era, barreling through the vacuum. It brutally struck the hidden, far side of our lunar companion. The devastating blow carved out a titanic depression known to astronomers as the South Pole Aitken Basin, plunging almost 5 miles downward and stretching nearly 1,500 miles across. The sheer scale is mind-boggling. To picture that, imagine a chasm stretching all the way from New York City to Dallas, plunging deep enough to completely submerge Mount Everest. Researchers now suspect that this apocalyptic strike acted like a cosmic shovel, dredging up primal matter from the lunar mantle. This extraordinary blend of subterranean elements is affectionately called CREEP, an acronym standing for potassium, rare earth elements, and phosphorus. Think of it as a pristine geological diary, locking away the chemical secrets of a time when the entire satellite was still a sloshing inferno. So what makes this shadowy cratered zone the ultimate treasure trove for modern astrophysicists? Well, for decades, the academic consensus painted a very specific picture of how the impact unfolded. The reigning theory assumed the rogue body attacked from a southern trajectory, plowing upward and spraying a massive wave of that radioactive treasure onto the upper northern boundary of the impact zone. However, fresh analysis completely flipped the script. The evidence now proves the fatal blow was actually struck from the north, forcefully ejecting all of those highly prized chemical remnants down into the southern perimeter. In a brilliant twist of fate, the precise landing zone for the upcoming Artemis 3 mission is aimed directly at that resource-rich southern boundary. Astrophysicists actually began doubting the original trajectory narrative after closely comparing this colossal lunar scar to other massive impact sites scattered throughout our stellar neighborhood, specifically looking at the Hellas Basin on Mars and the Sputnik Basin out on Pluto. When you look at the planetary maps side by side, a striking pattern emerges. Every single one of them shares a distinct, asymmetrical outline resembling a teardrop, or perhaps an avocado, bulging at one end while severely tapering at the opposite edge. In the world of orbital ballistics, that sharp tapered tip acts like a neon arrow pointing directly toward the attacker's origin. Applying that logic to our lunar basin confirmed that the devastating blow originated from the northern skies, debunking the southern strike hypothesis. To lock in this new theory, the scientific community dusted off archival records gathered by the Lunar Prospector probe. That intrepid little spacecraft relentlessly circled our satellite throughout 1998 and 1999. Its sensitive instruments meticulously mapped out radioactive signatures, pinpointing an incredibly dense pocket of thorium, one of CREEP's primary ingredients, blanketing the southwestern edge of the massive crater. With this geological goldmine mapped out, the stage is perfectly set for Artemis 3. This monumental endeavor represents humanity's grand return to the lunar dust, a feat we have not achieved since 1972. Assuming no major roadblocks, we are looking at a spectacular blast-off in the middle of 2027, hot on the heels of its predecessor, Artemis II. Speaking of which, that earlier mission, targeting a launch window prior to April 2026, serves as an ultimate orbital dry run. A brave crew will slingshot around the satellite and return without ever touching down, effectively taking our next-generation hardware out for a high-stakes cosmic joyride. The real nail-biter, however, is Artemis III. Space agency planners have meticulously scouted 9 incredibly rugged zones near the southern polar region, readying them for our historic, boots-on-the-ground return. The major hurdle right now is merely the ticking clock. The timeline for the third launch has been pushed back repeatedly, suffering the same scheduling fate as the second phase. Just for context, the inaugural flight, Artemis I, soared into the black back in 2022. That fully automated voyage flawlessly navigated the lunar orbit and splashed down without a hitch. The torch is now passed to Artemis II, pushing human explorers deeper into the cosmic ocean than we ventured in generations. Following that triumph, the crown jewel, Artemis III, will finally take center stage. The crew is slated to set up camp in the dirt for roughly 7 days, conducting groundbreaking geological fieldwork before firing their engines for Earth. Looking further ahead, missions 4 and 5 are tasked with constructing a revolutionary orbital habitat suspended right above the lunar terrain. Dubbed the Gateway, you can picture this structure as an interplanetary truck stop hovering in the void. Deep space travelers will pull up to dock, utilize the station as a temporary home for intense research, and stage their complex surface descents. It is an incredibly ambitious international project, combining the engineering might of various global space organizations, including key contributions from Europe and Japan. The primary transit vehicle ferrying these brave souls is the sleek Orion capsule, propelled upward by the awe-inspiring Space Launch System. This absolute behemoth of a rocket effortlessly dwarfs the Statue of Liberty and packs more than enough explosive thrust to hurl a manned crew straight toward our neighboring world. Once in position, the delicate final descent will rely entirely on the specialized human landing system. If all the rigorous safety trials are successfully passed, a modified version of SpaceX's towering Starship will ferry the very first crew down to the alien dirt. But let's zoom out for a second, because the lunar landscape is just the starting line. The ultimate grand vision spans from the moon all the way to the rusty deserts of Mars. The dream is to leverage every single technological breakthrough from the Artemis program to construct a permanent extraterrestrial outpost, laying the crucial groundwork to eventually catapult a human crew across the solar system to the Red Planet. And while they are up there kicking up the regolith, our daring explorers might just crack one of astronomy's most frustrating enigmas: the sudden ghostly flares and erratic glows that occasionally wash over the lunar plains. Let's pivot and unpack this celestial puzzle, right? Picture the evening sky on April 19, 1787. Legendary stargazer William Herschel was peering through his lens when he noticed an incredibly bizarre anomaly. A vivid, unexplainable beacon was radiating brilliantly from the unlit, shadowed sector of a new moon. The blinding flare persisted for hours, shining with an intensity rivaling distant stellar nurseries. Modern astrophysics has a formal name for the baffling spectacle he witnessed that night: a transient lunar phenomenon, commonly abbreviated to TLP. In simple terms, we are talking about abrupt, fleeting bursts of light or sudden chromatic shifts sweeping across the alien terrain. These bizarre events can manifest as radiant blotches, eerie violet or crimson stains, or even ghostly mists that materialize out of nowhere before vanishing into the vacuum. Throughout the past 2,000 years of human history, skywatchers have meticulously documented roughly 3,000 distinct instances of these bizarre flickers, tracking them through primitive spyglasses, modern observatory lenses, high-resolution sensors, or occasionally, just unaided, eagle-eyed observation. So, what cosmic wizardry is actually sparking these localized light shows? The frustrating truth is, there isn't just one tidy explanation. A whole chaotic cocktail of deep space forces can trigger these events, ranging from violent meteorite bombardments to subterranean gas venting, or even localized electrostatic storms. By carefully measuring the lifespan of the glow, which can vanish in the blink of an eye or burn steadily for an entire evening, researchers can gather vital breadcrumbs pointing to the true culprit behind the celestial magic trick. For instance, the absolute fastest outbursts, the ones winking out in under 60 seconds, are overwhelmingly the result of hypervelocity micrometeors violently slamming into the regolith. Believe it or not, a stray piece of space debris weighing no more than a simple pocket billiard ball packs enough kinetic fury upon impact to superheat the local terrain into a brilliant microscopic sun. The sheer thermal energy of the collision forces the surrounding stone to incandesk, creating a brilliant flare that rapidly dissipates as the vacuum saps away the heat. For decades upon decades, astronomers strongly theorized that these instantaneous light bursts were simply cosmic shrapnel raining down. Yet, definitive proof eluded them until the 1990s, when the widespread deployment of ultra-fast imaging tech finally caught the rocky bombardment in action. Have you ever stared at the night sky and noticed a sudden, mysterious spark on the moon? For the longest time, astronomers couldn't be sure if these brief blinks were real or just a glitch in their camera equipment. The only way to prove these lunar blinks were real was to capture the exact same burst of light from multiple observatories simultaneously. That breakthrough finally arrived back in 1999. Right in the middle of the Leonid meteor shower, stargazers actually caught verifiable footage of space rocks slamming into the lunar surface. From that moment on, we had undeniable evidence that our cosmic neighbor takes a constant beating from space debris. At first glance, these explosive impacts appear to be concentrated in specific regions, such as the massive, shadowy plains known as Oceanus Procellarum, or the Ocean of Storms. But that was simply an illusion caused by where researchers happened to be pointing their lenses. A comprehensive study published in 2024 revealed that these meteoroid strikes are actually distributed perfectly evenly across the entire lunar globe. However, what happens when a flash doesn't vanish instantly, but lingers for several minutes? That points to an entirely different phenomenon. Massive gas eruptions seeping straight out of the moon's interior. Research conducted in 2008 and beyond discovered that radioactive elements like radon can accumulate beneath the alien crust until they violently erupt outward. Imagine a cosmic pressure cooker suddenly blowing its lid. As this escaping radioactive gas breaks down in the vacuum of space, it creates a ghostly illumination visible all the way from our home planet. Fascinatingly, these shimmering patches align perfectly with regions already known for their unusually high radon concentrations. But the real puzzle lies in the endurance lights, mysterious glows that persist for hours on end, much like the brilliant beacon the astronomer William Herschel documented way back in 1787. A groundbreaking paper from 2012 proposed that these long-lasting lights are born from the solar wind, which is a relentless river of electrified particles blasting outward from our sun. When this stellar hurricane crashes into the lunar soil, it electrifies the dust. This electrical charge essentially levitates the dirt right off the ground, launching gigantic clouds of floating debris up to 60 miles into the void. Think of it like a floating mirror made of sand, catching and bending the distant light from neighboring stars and planets. This optical illusion tricks us into thinking the moon's surface is radiating its own light. With any luck, the upcoming Artemis landings will finally peel back the curtain on this lunar magic trick once their ground exploration begins. Honestly, the anticipation is absolutely electrifying. It is easy to assume our cutting-edge observatories have mapped every single inch of our orbital neighbor. But the universe loves to keep secrets. Down at the lunar South Pole, there are colossal impact basins that have not seen a single ray of sunshine for billions of years. These abysses are trapped in absolute darkness, plunging to temperatures even more freezing than the distant world of Pluto, making them extraordinarily hostile to any robotic explorer. Yet, humanity must conquer these freezing depths if we ever hope to journey deeper into the cosmos. Hidden within those pitch-black shadows are the exact ingredients required to sustain human life and fuel deep space voyages. We are talking about the ultimate cosmic treasure: frozen water, scattered as microscopic crystals throughout the desolate lunar dirt. Discovering hydration anywhere beyond Earth is a massive triumph. You are probably familiar with our absolute obsession with hunting down ancient riverbeds on Mars. If the red planet harbors even a drop of underground liquid, it sparks the tantalizing hope that extraterrestrial biology might have once thrived there. Finding so much as a single fossilized microbe would fundamentally rewrite human history. That is exactly why our robotic emissaries are currently prowling the Martian landscape, aggressively drilling into the bedrock like the galaxy's most determined botanists. However, as mind-blowing as a Martian oasis would be, uncovering frozen reserves right next door on the Moon is infinitely more crucial for our immediate future as a spacefaring species. The logic comes down to two simple factors: proximity and gravitational pull. A spacecraft can zip over to our local satellite in a mere 3 days. In astronomical terms, that is virtually instantaneous. For perspective, a luxury ocean liner takes at least 7 days just to cross the Atlantic from London to New York. But even more critical than the short commute is the strategic advantage of transforming the lunar surface into an interplanetary gas station. We could dock, top off the tanks, and blast off toward the uncharted depths of the solar system. The gravitational grip of the Moon is merely 1/6 as powerful as what we experience here on Earth. While that makes for fantastically entertaining slow-motion acrobatics, the real scientific benefit is how effortlessly a starship can escape its orbit. Blasting off from our home planet demands a colossal explosion of propellant simply to punch through our thick atmosphere and heavy gravity. Consider the legendary Saturn V rocket, the towering behemoth that hurled the Apollo crews across the void. Over 90% of that entire machine's weight was nothing but combustible liquid, necessary just to escape the launch pad. Escaping lunar gravity, by contrast, is a breeze, allowing us to pack massive amounts of cargo while burning a fraction of the propellants. Imagine finally being able to pack everything you actually want for a vacation without paying extra baggage fees. If engineers can harvest that lunar ice and synthesize it into high-grade starship propellant, it fundamentally changes the math of astrophysics, turning our rocky neighbor into an affordable, vital stepping stone to the outer planets. Beyond just propulsion, a little clever chemistry allows us to split those water molecules apart, providing pure, breathable oxygen for deep space habitats. Our future lunar pioneers will also rely on this very same melted frost to hydrate themselves and cultivate extraterrestrial greenhouses. So where exactly do we stand with these cutting-edge revelations? For generations, astrophysicists firmly believed the lunar landscape was a bone-dry desert. However, in 2009, the team at NASA deliberately slammed a high-speed projectile deep into a shadowed basin. The resulting impact threw up a majestic plume of vaporized frost, like a grand finale at a fireworks show, definitively proving our celestial companion was holding on to hidden reservoirs. The real question became, just how much liquid was hiding up there? The answer is staggering. Current analytics point to hundreds of millions of tons of crystallized frost entombed within those frigid polar extremes. Advanced calculations estimate the payload at roughly 1.3 trillion pounds. To put that massive number in perspective, picture the combined mass of 460 million automobiles. We are not talking about vast, swimmable oceans, but it is an absolute game changer. And the crazy part is, we might have only scratched the surface. Beyond sustaining human colonies, this frozen gold mine could unlock profound secrets about our cosmic origins. Because this material has been frozen solid since the dawn of our solar system, it acts as a pristine, ancient time capsule. By analyzing its molecular structure, we might finally solve the riddle of how the oceans were delivered to Earth in the first place. Which begs the ultimate question: how did such an astronomical volume of frost end up on a desolate, airless rock to begin with? Astrophysicists theorize that a vast portion of it hitchhiked across the galaxy aboard rogue comets and wandering asteroids during the chaotic, early days of planetary formation. Whenever these icy wanderers violently crashed into the poles, they left behind frozen souvenirs. Alternatively, a chemical reaction triggered by the relentless bombardment of the solar wind against oxygen-rich lunar dust might have slowly manufactured these molecules over eons. Regardless of its exact origin story, the true marvel is how perfectly it has been preserved within these jagged polar sanctuaries. While scattered frost exists elsewhere, the absolute largest and most reliable glacial deposits are safely tucked away at the extreme southern edge of the globe. The scale of these impact basins is genuinely difficult to wrap your head around. Take the legendary Shackleton crater, for instance, a yawning chasm stretching over 13 miles across and plunging more than 2 miles straight down. That makes it nearly double the terrifying depth of the Grand Canyon. Because our satellite spins with an exceptionally slight axial tilt, measuring a mere 1 degree, the blinding rays of the sun never managed to crest the towering walls of those impact zones. Down in the absolute dark, the thermometer plummets to a bone-chilling -400 degrees Fahrenheit, perfectly preserving anything trapped in the dirt like an eternal cosmic deep freeze. One of the most breathtaking visual contrasts in the entire solar system happens right there at the southern pole. While the floors of these craters are doomed to an eternity of absolute blackness, the towering, jagged mountain ridges just above them bask in almost continuous, glorious sunshine. Astronomers poetically refer to these illuminated summits as the peaks of eternal light. Have you ever imagined a place where eternal sunlight directly borders unending darkness? The lunar poles offer exactly that, creating the ultimate sweet spot to bask in endless solar power while remaining just steps away from frozen, buried riches. In this bizarre frontier, perpetual daylight and absolute shadows share the exact same real estate. Yet stepping into those pitch-black craters is a highly lethal gamble, not just a neat cosmic quirk. You are looking at a landscape so brutal and punishing that recreating it in an earthbound lab is completely impossible, leaving us totally blind to what actually hides deep within its belly. Picture trying to navigate the absolute harshest frozen wasteland of Antarctica with zero visibility. The moon's shadows are infinitely more treacherous. Which brings up a massive question. Can we actually harvest those hidden lunar oceans? Unlocking that secret could literally spawn an industry worth trillions of dollars. Because while we know the hydration is definitely present, extracting it is nothing like just carving out a block of glacier. Imagine trying to filter out microscopic frost flakes completely blended into razor-sharp dirt. Harvesting it requires hardcore robotics to bake the dirt and trap the evaporating mist before the vacuum of space swallows it whole. Add the extreme cold to the mix, and things get wildly complicated. If a brave astronaut or an armored machine somehow survived the drop into those abysses, moving around would be a nightmare. Standard power cells and gears would almost instantly fail, while relying on solar energy in the total dark is a massive dead end. Down there, modern circuitry simply turns into solid ice cubes within moments. But humanity is fighting back. NASA deployed an advanced scouting satellite armed with powerful radar arrays to virtually peel back the darkness. Furthermore, they just unleashed an absolute game changer: the Shadow Cam. This optical marvel is engineered to pierce through gloom 100 times darker than human vision can tolerate. Think of it as the most overpowered set of night vision goggles ever created. Suddenly, we possess the power to chart these terrifying drop-offs without risking a single life. Armed with this thermal map, brilliant minds are cooking up some incredibly wild extraction schemes. Picture massive atomic-fueled vehicles beaming blinding floodlights into the void. Other scientists envision mechanical spiders rappelling down sheer cliffs or acrobatic drones bouncing across the jagged rocks. There are even blueprints for thermal boring machines designed to liquidate the permafrost, collecting the resulting steam much like the sweat dripping down a chilled beverage glass on a hot summer afternoon. The beautiful part of this cosmic puzzle? Those frozen reserves are permanently locked in place. They will patiently chill in the dark until human ingenuity catches up to claim them. And we aren't waiting around doing nothing. In reality, global aerospace factions are locked, loaded, and prepping over 6 different expeditions to launch within the next couple of years. NASA's monumental Artemis initiative is currently fueling up to slingshot human explorers around our rocky neighbor before finally touching down right at that treacherous southern frontier. Meanwhile, the Chinese Chang'e 7 probe is plotting its own course into those shadowy depths, alongside commercial heavyweights such as Firefly and Blue Origin. They are all racing to drop cutting-edge hardware onto the surface. Speaking of exploring, did you know about this bizarre little secret? Our pristine satellite actually carries a distinctive stench. The moment Apollo legends tracked that extraterrestrial dirt into their pressurized cabins, it clashed with the breathable air and released a seriously overwhelming odor. To them, it reeked exactly like spent ammunition or the smoky aftermath of a massive firework display. Now, space dirt contains 0 actual explosives, but those microscopic shards are incredibly volatile after baking in a raw cosmic vacuum for billions of years. The second those ancient grains hit a breathable atmosphere, they sparked a chemical reaction that produced that intense, charred aroma. You can bet the next generation of space pioneers will get a huge whiff of that exact same fragrance, considering the grime clings relentlessly to every surface. Fingers crossed that planetary architects are factoring heavy-duty deodorizers into those future habitat blueprints. But what if I told you the strangest mysteries aren't on the surface, but buried deep inside? Forget visible tectonic quakes. There is a bizarre phenomenon occurring right under our noses, miles below the crust, where we assumed everything was a dead, petrified tomb. Geologists recently stumbled upon a bizarre, squishy interior barrier that can only be described as lunar sludge. Think back to elementary science class. Our world is built like a jawbreaker, and so is our satellite, sporting an outer shell, a thick middle, and a center. The catch is, this extraterrestrial heart is incredibly tiny. While our homeworld boasts a massive, roaring engine that accounts for a full 33% of its total weight, the lunar center is a mere blip, contributing barely 1 to 2% to the whole. Its width is just a fraction of the entire sphere, encased tightly by a rigid, stony shell. Yet, sandwiched right between that solid middle and the central pit, lies that enigmatic, mushy substance, holding secrets that could change everything. This semi-liquid zone behaves surprisingly like Earth's ocean water, constantly swelling and retreating. It flexes and pulses with an eerie rhythm, almost as if the celestial body is breathing. Rather than violent churning, it performs a perfectly timed, delicate subterranean waltz. We are all familiar with how our neighbor's gravitational tug yanks our oceans back and forth. Fascinatingly, the payback is mutual. Our own planet, along with the sun, physically stretches this buried molten sludge in an endless cosmic tug-of-war. Even wilder, researchers suspect this squishy zone is absolutely loaded with a mineral called ilmenite. Why does that matter? Because ilmenite is basically a treasure chest of titanium. Here on terra firma, we are obsessed with this nearly indestructible yet incredibly feather-light element. It forms the backbone of commercial jets, interstellar rockets, and even life-saving surgical implants. You will even find it reinforcing premium bicycles and high-end computers simply because it laughs in the face of extreme temperatures and outright refuses to rust. Discovering an underground sea packed with this stuff is basically striking the ultimate cosmic jackpot. As visionaries actively draft up blueprints for permanent off-world colonies, having an infinite on-site supply of raw construction metal to forge habitats, vehicles, and survival gear is a total paradigm shift. The alternative would be dragging heavy steel out of Earth's gravity well, an undertaking that would burn through astronomical piles of cash. Ultimately, this revelation proves once and for all that the rock floating in our night sky is not a dead, static wasteland, but an active, breathing entity. There is literal geologic magic happening beneath its crust. To crack this mystery, NASA deployed a pair of highly specialized investigative weapons. The Gravity Recovery and Interior Laboratory partnered with their elite orbital surveyor. Both of these brilliant engineering marvels were dispatched to decode our satellite's secrets. However, rather than just snapping pretty photos of the craters, they were built to map invisible forces, specifically tracking how the gravitational pull morphs and flexes day by day. The Grail project launched twin robotic scouts, charmingly dubbed Ebb and Flow, into lunar orbit. Pretty fitting names, right? These twin machines were programmed to cruise in tight formation, meticulously recording the most microscopic fluctuations in the celestial body's magnetic grip. Imagine them acting like a pair of hypersensitive scales, physically feeling the terrain's hidden tug. Whenever they glided over a patch of dense, heavy mass, the invisible force would yank the two drones closer together, while hollow areas would let them drift apart. This brilliant orbital dance allowed researchers to X-ray the interior without digging a single hole. Going out in a blaze of glory, the dynamic duo was deliberately smashed into the rocks in late 2012 to conclude their service. Meanwhile, the companion surveyor took a vastly different approach. That secondary probe acted as an ultra-high-definition sniper camera, grabbing jaw-dropping images and scanning the topography. By fusing the visual data with those gravity maps, scientists finally unlocked the secret of the hidden molten sludge. Have we been completely wrong about the rock orbiting our planet all along? Finding this hidden sea of magma entirely flips the script on lunar science, leaving us to wonder, where did this liquid rock even come from? How many eons has it been trapped down there? And the real billion-dollar riddle here, how in the universe has it maintained its intense heat for millions of years without cooling down? Sure, the heart of our celestial neighbor produces warmth much like our own home planet does. However, we cannot simply brush this off by assuming that central furnace is solely responsible for keeping things liquefied. To begin with, the lunar center is a tiny, sluggish fraction of ours, meaning its thermal output is incredibly weak by comparison. Furthermore, our night sky companion is fundamentally a freezing world, with surface conditions plunging to a bone-chilling -200 degrees Fahrenheit. So, what exactly is keeping this subterranean blanket of sludge perfectly runny? Science is still scratching its head. Regardless, this underground syrup might just be the skeleton key to unlocking several lunar secrets. Take those mysterious tremors that ripple across the satellite, for instance. Experts now suspect these quakes are directly caused by this very blanket of warm mush sloshing around deep underground. And if we look at the bigger picture, this revelation speaks volumes about the rest of the cosmos. Imagine this. If a floating boulder we once deemed completely dead and silent is secretly harboring this much internal drama, what does that mean for neighboring worlds? Are countless other space rocks and distant satellites also masking restless, churning guts just out of sight? Unlocking this puzzle might even hand us the missing pieces to our own terrestrial history, shedding fresh light on the invisible gravitational dances that drive our oceans. The breakthroughs just keep rolling in up there, especially when we peek right below the outer crust. We are talking about colossal underground voids that have sat in total darkness for eons. For more than 50 years, researchers have harbored a hunch that this desolate landscape is secretly hollowed out with sprawling subterranean networks. Experts classify these sprawling passages as magma channels, as they were literally carved out by liquid fire. Obviously, countless millennia ago, our orbital companion was a violently chaotic world. Frequent tectonic outbursts would violently spew molten rock across the barren plains. Picture a river of fire, where the topmost skin hits the freezing vacuum of space, rapidly solidifying into a pitch-black, rocky ceiling. In fact, when you gaze up at the man in the moon, those familiar shadowy patches are exactly that. Vast oceans of petrified magma. Beneath that freshly hardened crust, however, the fiery current just kept surging forward. Once the eruption finally choked off and the liquid drained out, it left behind a sprawling, empty vein, a perfect geological pipeline. We see this exact same architectural wonder right here at home in volcanic hotspots like Hawaii and Iceland. That identical fiery carving process shaped the lunar underworld billions of years in the past, except the off-world versions are scaled up to absolutely mind-bending proportions. Astronomers now believe these alien caverns could rank among the most gigantic tunnel networks floating anywhere in our local cosmic neighborhood. A prime example was recently mapped right underneath the Sea of Tranquility, the very spot where the Apollo 11 mission first set foot. plunging an astonishing 340 feet down into the dark. These cavernous arteries have been resting quietly right under the cosmic floorboards, perfectly preserved and completely unbothered since the dawn of time. It is only within recent days that we finally snagged the hard proof they exist. A team of brilliant minds out of Italy's University of Trento cracked the case by pairing cutting-edge ground-penetrating signals with heavy-duty algorithmic mapping. Think of it like a technological X-ray. They shoot electromagnetic pulses straight down into the dirt. Those invisible echoes bounce back up, painting a ghostly picture of the buried architecture. By carefully decoding exactly how those signals deflected off the subterranean rock, the research crew successfully outlined the sheer scale and geometry of these buried halls. The most thrilling part of this breakthrough? We just found the ultimate real estate for future human settlements. These rocky vaults offer a naturally bulletproof shield against deadly cosmic rays, brutal solar gales, and the constant barrage of micrometeorites. Even wilder, aerospace engineers have tracked thermal signatures suggesting these depths hover perpetually around 63 degrees Fahrenheit. That is basically a perfectly air-conditioned living room in the middle of a deadly wasteland. Throw in the distinct possibility of trapped ice, and these geological shelters might just become the very foundations for sprawling, self-sustaining, off-world cities. Now, let us address the elephant in the room. Are we going to stumble into some terrifying alien predator lurking in the shadows? While plunging into these black depths promises unparalleled scientific treasures, and we might miraculously stumble upon fossilized microbes, there is a 99% guarantee that zero chest-bursting creatures are waiting for us in the dark. The utter lack of a breathable atmosphere and brutal environment makes complex biology mathematically impossible. Still, it paints a fabulous picture for a sci-fi thriller. For now, the plan is to deploy autonomous rovers and scouting drones down the drop-offs to verify structural safety before any astronaut unclips their tether. Furthermore, America is not the only player eyeing this prime cosmic real estate. The Chinese Space Agency is aggressively researching these very same subterranean voids for their own planetary outposts, proving that the modern sprint to colonize the stars is shifting into overdrive. Think back to the legendary frontier days of the 19th century. Throngs of dreamers swarmed the muddy riverbanks of California, sifting the dirt for a glimmer of absolute fortune. Well, strap in, because economists believe we are on the verge of the great lunar rush. Estimates suggest a staggering $1 trillion worth of rare elements is quietly sleeping just beneath the gray regolith. That is a genuinely earth-shattering amount of wealth. The real puzzle, though, is figuring out the logistics of hauling it back and untangling the legal nightmare of who actually holds the deed to outer space. Take a closer glance at any high-resolution snapshot of our satellite, and you will instantly spot a landscape absolutely battered by impact scars. The sphere looks exactly like a block of heavily aged Swiss cheese, boasting upward of 1,300,000 indentations spanning more than 6 miles across. However, the true treasure map points to roughly 6,500 absolute behemoths. We are talking about colossal depressions stretching over 12 meters from rim to rim. These massive dents were not excavated by highly advanced extraterrestrials with mining lasers, but by a relentless eons-long bombardment of rogue space debris. After cross-referencing orbital topography maps with the chemical makeup of fallen meteors and running the massive calculations, astrophysicists are convinced these impact bowls are brimming with unmined platinum. The most jaw-dropping detail? This cosmic motherlode might be buried mere inches below the dusty topsoil. Since this barren world lacks any sort of protective atmospheric bubble, it never experiences the erosive chaos of storms, flowing water, or grinding tectonic shifts. Consequently, whenever a treasure-laden comet slammed into the dirt, its precious cargo remained frozen exactly where it hit, gathering nothing but cosmic dust for countless ages. Every single one of these impact zones acts like a gargantuan cosmic catch basin, trapping raw iridium, palladium, and platinum. Down here on our homeworld, mining companies must carve miles into the bedrock, simply to scrape together microscopic flakes of these exact materials. Interestingly enough, Did you realize the vast majority of the gold we wear around our necks was originally delivered by primordial falling stars? During our planet's fiery infancy, all of the native heavy metals immediately plummeted straight down into the molten heart of the globe. The glittering seams we are able to harvest today were merely a late delivery, sprinkled across the outer shell by cosmic collisions billions of years in the past. This naturally begs the question, why not simply skip the middleman and intercept the rogue rocks directly? Truthfully, the logistics of deep space interception are an absolute nightmare. While harpooning a floating asteroid is mathematically possible, plucking resources straight from our closest orbital neighbor is astronomically simpler and infinitely cheaper. Have you ever wondered why our moon holds more promise than any other colossal boulder drifting through the cosmic ocean? After all, humanity has already left footprints in its dust and hauled lunar souvenirs back home, which means we know it intimately. Targeting the moon for a cosmic gold rush just makes infinitely more sense than chasing rogue asteroids, though those unpredictable space rocks are definitely next on our cosmic itinerary. But here is the fascinating part. Harvesting lunar resources is not merely about finding shiny treasures. Nestled within those deep, shadowed craters lies a far more precious commodity: frozen water. We can say this with certainty because brilliant robotic scouts like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1 have detected layers of ancient frost hidden in the permanent darkness near the lunar poles. Think of this ice as the ultimate cosmic treasure chest. Why? Because you can split water into hydrogen and oxygen, the exact ingredients required to brew high-octane rocket fuel. We could even purify it into drinking water for intrepid astronauts, or use it to nurture extraterrestrial greenhouses. Just picture a bustling lunar gas station where starships pull in to refuel before blasting off toward the outer planets. That scenario is not just mind-blowing, it is an absolute game-changer for space travel economics. Escaping Earth's gravity is incredibly expensive, so launching with an empty tank and filling up in space saves mountains of cash and energy. And if we are already pulling over at the moon for a pit stop, why not unpack our bags and build a permanent outpost? We are talking about constructing a fully functioning off-world civilization, transforming our gray neighbor into a cosmic springboard to propel humanity deeper into the Milky Way. A thriving lunar base would serve as a playground for scientists to observe extreme stellar phenomena, monitor chaotic solar winds, perfect the art of building alien habitats, and unleash rovers into genuine, razor-sharp moon dust. Honestly, I cannot be the only person eager for a future where robotic explorers live stream their adventures straight from the lunar surface. Every single survival trick we master up there will act as the crucial stepping stone for colonizing the rusty deserts of Mars, or eventually diving into the icy oceans of Jupiter's moons. Now, before you dismiss this as pure science fiction, consider reality. Visionary companies like Astroforge and Carmen Plus are already engineering the technology to excavate asteroids and, inevitably, the lunar surface. Meanwhile, NASA's legendary Artemis program is pushing the envelope to establish a long-term, sustainable human footprint on the moon within the current decade. The European Space Agency is also eyeing those celestial riches. So, the dream of humans and advanced machines working shoulder to shoulder under the starry lunar sky is not a matter of if, but simply when. Yet, venturing into this uncharted territory brings up immense, gravity-defying complications. We are staring down some of the most profound dilemmas humanity has ever faced. Much like the rugged gold rushes of the past, the cosmos is essentially an untamed frontier with barely any sheriff in sight. The historic Outer Space Treaty, penned back in 1967, clearly states that no single nation can plant a flag and claim the moon as their own. However, that ancient document is incredibly murky regarding private corporations scooping up cosmic loot. So, if an ambitious billionaire builds a spacecraft and starts digging up lunar platinum, do they get to keep the shiny spoils? Right now, that remains a multi-trillion-dollar guessing game. Global leaders are frantically negotiating the fine print, hoping to establish order before this celestial gold rush devolves into a chaotic, interplanetary free-for-all. Beyond the legal nightmare, we also face the monumental task of preserving the moon's pristine alien ecosystem. Certain ancient craters are shrouded in such profound, undisturbed silence that astronomers dream of transforming them into gargantuan deep space observatories, perfectly shielded from the chaotic radio chatter of Earth, allowing us to listen to the whispers of the early universe. Plunking a heavy mining operation next door could send disruptive vibrations through the crust or kick up a storm of jagged particles. That floating regolith could easily shred delicate lenses and absolutely wreck billion-dollar scientific instruments. Wrecking a lifetime of astronomical research is a surefire way to enrage the scientific community. Furthermore, vast stretches of the lunar landscape remain pristine and untouched, and reckless excavation might bulldoze incredible geological wonders before we ever get to study them. In essence, humanity must walk a fine line to ensure we do not pave over our celestial companion, turning a mysterious world into a dusty industrial wasteland before unlocking its deep space secrets. To prevent a cosmic tragedy, visionary experts are proposing the creation of off-world preservation zones. Think of them as lunar national parks, strictly off-limits to mechanical diggers and corporate drills. This brilliant compromise would allow us to harvest essential materials while guarding the moon's most scientifically vital regions for future generations to explore and marvel at. But let us bring this down to Earth with a massive question. How will this cosmic endeavor impact the everyday people who cannot simply rocket into space with a metal detector on a Sunday afternoon? The exotic metals buried in the lunar crust are not merely financially lucrative. They hold the key to unlocking next-generation technology. For instance, the highly coveted platinum group metals, which are likely scattered throughout the regolith, act as the critical backbone for life-saving medical devices, advanced satellites, and revolutionary clean energy fuel cells. If our rocky neighbor truly harbors a multi-trillion-dollar jackpot, it could hyper-accelerate our tech industries and drastically reduce the cost of everyday electronics. But wait. The real star of the show is helium-3. This incredibly rare isotope coats the lunar surface like a fine dusting of magic, and physicists believe it is the holy grail for nuclear fusion, a staggeringly powerful, limitless energy source that produces zero suffocating greenhouse gases and absolutely no dangerous radioactive waste. If we finally crack the fusion code, just a few scoops of helium-3 could illuminate entire megacities for years. Imagine the profound ripple effect. By tapping into the solar system's endless bounty, we could dramatically scale back the destructive mining operations tearing apart our home planet. Sourcing materials from the void means allowing Earth's battered ecosystems to heal, paving the way for a genuinely sustainable future to support our rapidly expanding human family. Conversely, hauling space rocks back home opens Pandora's box of global friction. We are almost guaranteed to witness an intense, high-stakes geopolitical tug-of-war over who controls this infinite cosmic wealth. The fear of missing out on the greatest resource rush in human history will push nations to the brink. Ultimately, tearing into the lunar surface is far more than a whimsical laboratory experiment. It is a colossal paradigm shift, poised to radically rewrite global economics, propel our technological evolution, and reshape our planetary environment, either saving us or creating entirely new catastrophes. Back when I was growing up, which feels like centuries ago, glossy science textbooks boldly featured domed cities on the moon. The harsh truth behind why crewed lunar missions ground to a halt was brutally simple. The math just did not make financial sense. Why would any sane government incinerate mountains of taxpayer cash to reach a barren wasteland devoid of economic payoff? Yet, as the cosmos always does, our understanding has evolved. Knowing what cosmic treasures lie hidden in the dust changes the entire equation. Honestly, I can already picture myself clocking in for a 9-to-5 shift inside a lunar dome, repairing rusty rovers and tending to zero-gravity tomatoes. Let us reel it back down through the atmosphere for a moment. No corporation is franchising fast food joints on the Sea of Tranquility, and you cannot book a lunar vacation rental quite yet. Even the most starry-eyed visionaries admit we are still several decades out from large-scale extraction or bustling off-world colonies. In the near term, humanity's cosmic outreach will rely on robotic pioneers performing risky experiments, backed by budgets large enough to make your head spin. So until the day they issue us our very own pressurized lunar hard hats, this magnificent future remains a wondrous concept to ponder the next time you gaze up at the glowing night sky. And who knows what unimaginable secrets are still hiding in plain sight on the bright side of the lunar sphere. As we look to the stars, imagine this. You are standing on the moon, but suddenly the ground beneath you begins to throb. Every instinct screams danger as the seemingly dead world holds its breath for a split second, before a violent, shuddering shockwave knocks you right off your feet. Could the mysteries of the universe be waking up, throwing a literal moonquake our way? Have you ever stared up at the night sky and assumed our moon was just a silent, dead rock? Well, grab your telescopes, because fresh data proves that old assumption is completely backward. The brilliant minds over at the University of Maryland just spotted 266 bizarre wrinkles hiding on the dark side of the moon. And get this, those fresh scars strongly hint that the lunar surface is still tossing and turning. Wait, does that mean actual moonquakes are shaking things up there? Sort of. These newly found grooves sit right inside ancient volcanic zones born 3.2 to 3.6 billion years ago. Yet they look surprisingly fresh out of the oven. You will usually spot them huddled together in groups of 10 to 40, deliberately popping up wherever the lunar crust happens to be naturally flimsy and prone to cracking. Just a quick heads up though, when stargazers say recent, they aren't talking about something that happened last Tuesday or even back in the 90s. For the longest time, computer simulations told us that all the rumblings stopped around 2.5 to 3 billion years back. However, this groundbreaking intel strongly suggests these rocky wrinkles have actually been shifting and grooving within the last billion years. A handful of the tinier cracks look like they popped up a mere 200 million years ago, which is practically yesterday in cosmic time. Basically, our orbital neighbor might still be getting a celestial facelift right now. Findings like this completely flip the script on how we thought the lunar landscape evolved over the eons. But how on earth did the experts actually figure all this out? Teaming up with the Smithsonian Institution, the Maryland crew used a clever technique called crater counting to put a timestamp on these strange lunar wrinkles. Think of it like reading the wrinkles on a face. A smooth surface with very few dents means it is young, while a heavily battered and scarred area has been sitting around way longer. On top of that, close-up scans revealed some ridges slicing right across older impact zones, pegging their birth at roughly 160 million years back. For planetary geologists, that is incredibly modern, hinting that the underlying engine driving these fractures might still be purring today. Even cooler, the cracks facing Earth look practically identical to the ones hiding on the far side, proving that whatever mysterious forces are twisting and bending the crust are acting globally across the entire sphere. Picture the moon acting like a giant drying sponge. It is slowly shrinking, cooling down, and getting constantly tugged by orbital gravity. Hold that thought. We will dive deeper into those mechanics shortly. Want more proof that our silver companion is alive and kicking? Just blow the dust off the vintage records from the legendary Apollo landings. Those astronauts actually caught surface tremors in action, using their trusty seismic gear to log 28 distinct quakes measuring anywhere from a magnitude 1.5 to 5. Today's experts are betting that those exact fault lines are the smoking guns behind all this modern trembling. Now, let us unpack this wild concept of a shrinking celestial body. Picture the ultimate cosmic car crash. 4.5 billion years ago, a rogue planet the size of Mars slamming directly into a newborn Earth. That apocalyptic smash-up blasted mountains of boiling rock straight into the void. Gravity eventually swept all that fiery debris into a ball, creating our moon. Back then, it was nothing but a chaotic glowing ocean of magma continuously rocked by savage eruptions and violent quakes. So yeah, our serene nightlight started out as a terrifying floating fireball. But at what point did it finally cool off and harden? The brilliant folks in the lab finally nailed the exact date down to 4.43 billion years ago. That freeze-over was a colossal milestone, both for the newly minted moon and for us down here. Think about it. That devastating collision up in the heavens was likely the crucial reset button that finally gave Earth the perfect, stable conditions needed to brew up living things. Fast forward through billions of trips around the sun. the scorching rock slowly chilled and shrank like a dying ember. Which brings us to the gorgeous, silent silver orb we see out our windows today. Except, it is not totally frozen solid to the core just yet. The deep interior is still bleeding heat into space, and that agonizingly slow chill is likely the hidden motor keeping the surface alive. As the inner heart cools, the whole structure tightens like a deflating balloon, forcing the brittle outer crust to snap, buckle, and cave. The ultimate proof of this celestial squeeze is stamped right across the Luna Maria. You know those giant, shadowy stains you can see with the naked eye? Those flat plains were born when oceans of ancient lava flooded out, massive craters left by asteroid strikes turning into solid rock. As the whole globe shrank over the eons, that hardened crust bunched up, creating the exact rippled scars we see today. On top of the temperature drop, Earth itself plays a huge role by constantly locking its little buddy in a brutal gravitational tug-of-war. Being endlessly stretched and pulled by our planet's gravity builds up intense stress, causing the crust to fracture and shift. Now, all this space drama sounds thrilling, but does a twitching moon actually matter to us back home? Honestly, it absolutely does. We have always daydreamed about turning that silent wasteland into a rock-solid foundation for futuristic colonies and off-world mining operations. But finding out the ground is literally quaking beneath our feet changes everything. If the terrain randomly buckles, any multi-billion-dollar habitats, power grids, and resource extractors could be instantly wiped out. Because of this, outfitting rovers with high-tech quake detectors and deep scanning radar is our #1 priority to map out these hidden fault lines. We have to chart every single hazard zone before we even think about setting up a permanent neighborhood up there. Oh, and speaking of lunar nightmares, there is an incredibly annoying villain waiting for the next wave of explorers. Moon dust, officially known as regolith. The Apollo pioneers quickly discovered that this razor-sharp, static-charged powder is like glitter from hell, ruining spacesuits, jamming up machinery, and wreaking havoc on human lungs. And guess what? A brand new study from the engineers at Texas A&M just uncovered yet another terrifying twist. The sheer force of rocket engines blasting off or touching down turns this abrasive dirt into a high-speed sandstorm, acting like shrapnel that can easily destroy nearby equipment, which is a massive red flag when you have a busy highway of shuttles dropping off crews and supplies. This extraterrestrial gravel ranges from microscopic specks to gigantic boulders, but the main ingredient is fine silicate glass around 70 microns thick, roughly the exact width of a single human hair. Imagine billions of years of cosmic bombardment, with endless meteorites relentlessly pounding into the rocks, until the whole landscape was pulverized into a sea of jagged flour. But here is the kicker. Without a thick, cozy atmosphere like we have down here, there are absolutely no oceans or breezes to polish those razor-sharp edges away. Worse yet, getting constantly blasted by solar radiation turns that grit into a highly static nightmare, acting like a magnet that instantly clings to whatever it touches. The original moonwalkers learned this brutal lesson instantly as the dark soot glued itself to their visors, snuck into the living quarters, and ruined their gear. To make matters worse, inhaling the stuff triggered serious allergic reactions, leaving the brave crews with bloodshot eyes and hacking coughs the moment they took their helmets off. However, figuring out how to vacuum up space dirt is a headache for tomorrow's astronauts. The ultimate holy grail right now is hunting down usable water to keep these futuristic missions alive, and China is stepping up to the plate to crack the case. They are currently gearing up for a massive expedition to sniff out buried glaciers, launching the ambitious Chang'e 7 mission in 2026. Have you ever wondered what cosmic secrets lie hidden in the pitch-black shadows of our night sky? Soon, an advanced airborne drone will plunge into the yawning chasms of the lunar South Pole, hunting for ancient, frozen reservoirs. A discovery that would completely rewrite the playbook for stellar exploration. Imagine deep space pioneers having a ready-made oasis for drinking water and rocket propellant right there in the void. This ambitious endeavor forms a critical pillar of the Chinese aerospace roadmap, which aims to plant human footsteps back on lunar soil within just 5 years. We have certainly caught whispers of hydration out there before, glimpsed in the alien dirt brought back by the Chang'e 5 module, and spotted by observation satellites launched from the United States and India. However, astrophysicists are convinced that massive subterranean glacial vaults hold the true secret to sustaining long-term planetary outposts. Down at the southern axis of this pale orb lie impact craters of absolutely staggering depth. Plunged in eternal darkness, these abysses are the perfect hiding spots for primordial frost. Once it touches down, the hovering probe will dive straight into the darkness to investigate. And a confirmed strike would drastically slash the exorbitant cost of cosmic colonization, transforming a harsh, dead rock into a sustainable staging ground where pioneers can actually survive and thrive. Beyond mere survival, scholars suspect these frozen time capsules might even whisper clues about biology beyond Earth. Regardless of whether we conquer the abrasive lunar regolith and secure a steady water supply, spotting freshly formed geologic wrinkles on the surface has already flipped our understanding upside down. Should this pale sphere turn out to be trembling with internal heat, it proves we are shockingly ignorant about the celestial companion parked right in our own cosmic backyard. What other mind-bending mysteries are buried under that gray dust? Are we truly ready to accept that the silent, static orb hanging above us is actually a living, breathing world? Upcoming voyages, which suddenly carry a lot more peril than we originally calculated, are bound to reveal the raw truth. So I suppose it is finally time to abandon my childhood fantasy that the whole thing is crafted from dairy. Not even a single slice of cheddar up there. Whether it looks like a glowing marble, a bright crescent, or a silver semicircle in the sky, this heavenly body conceals complex subterranean strata identical to our home planet, anchored by a deep central heart. Roughly 2 decades passed. Stargazers tracked the subtle wobbles in its orbital spin, determining that a liquid envelope swirled deep underground. Yet the absolute center remained completely veiled in mystery. For years, the scientific community debated whether that deepest nucleus was a hardened boulder or a churning cauldron of magma. Today, the fog has lifted, thanks to a treasure trove of telemetry gathered from historic voyages, heavily relying on the legendary Apollo expeditions. Those brave pathfinders brought back critical hands-on measurements, which modern researchers have brilliantly combined with the fascinating science of acoustic geology. This technique relies entirely on mapping how vibrations ripple through solid matter. Picture a powerful tremor shaking the ground, right here at home. Such a violent rupture sends energetic pulses echoing through the bedrock, allowing geophysicists to capture those signals and basically X-ray the guts of our world. That exact same principle works beautifully for unlocking the secrets of neighboring planets and, naturally, our own orbital companion. Whenever a tremor shudders across its barren plains, it sends distinct acoustic ripples downward. By tuning into those faint echoes, researchers can sketch an incredibly precise blueprint of the concealed anatomy, peeling back the subterranean crust to identify unique geological zones, figuring out their chemical makeup, and mapping their exact architectural order. To probe the absolute deepest reaches of this celestial body, experts also shoot concentrated light beams into the cosmos, an ingenious technique calculating the exact millimeter gap spanning from our terra firma to the lunar crust. The verdict is finally in. The heart of our orbital partner is a heavy, compressed sphere of solid iron, perfectly mimicking our own. Stretching roughly 310 miles across, it takes up almost 15% of the entire globe's diameter. Moreover, brilliant minds have unearthed clues validating an epic cosmic concept. The thick layer sandwiched beneath the crust, known as the